Hello friends, welcome to session 3 on projection of plane surfaces. Again, I'm telling you, in session 3 we'll continue with top view starting problems. See here, I have already told you for a triangular lamina, if you draw one triangle with one of the edges perpendicular to XY line, you can manage both edge on HP or corner on HP as we have done in the past. But when it comes to square lamina, edge position will be different, corner position will be different. Now I am telling you about the edge position here. Now as you see here, ABCD is a square lamina means when you are looking from here, B dash A dash, this is C dash D dash, this is the front view. This front view when it is lifted, no, when you lift above, if you lift C dash D dash up, it will be resting on B dash A dash and HP. If you lift B dash A dash up, it will be resting on C dash D dash and HP. That's why if you draw square in this position, it can be only edge on HP. Okay, it can be only edge on HP. For if you want corner on HP, you have to change the position. Many people do mistakes here only. When they say edge on HP, you take corner on HP. When they say corner on HP, you take edge on HP. That is why this you have to be very careful. When edge is on HP, for a square lamina or a square pyramid or square prism or cube, you have to start in this way only. Take care of the initial position. Okay. See here, a square lamina of size 40 has an edge on HP inclined at 45 degrees to VP with the surface of the lamina inclined at 30 degrees to HP. Draw projection. Sir, see here. Now you draw XY line, you draw VP HP. Whatever you draw here will be the front view. Whatever you draw here will be the top view. Now, square lamina edge position means compulsorily you show, as I told you, you do this way with one of the edges perpendicular to XY line. Okay, A, B, C, D, B dash, A dash and C dash, D dash. Okay, this is 40 mm square lamina, XY line, VP, HP, everything you make it. Now, you see here, as I said, it is square lamina has an edge on HP with surface of the lamina inclined at 30 degrees to HP. Okay, that is why now you lift this up. Even you could have lifted this way, yeah, this way also. C dash, D dash. Both are correct. Okay, you can either lift C dash D dash up or B dash A dash up. Now I have lifted C dash D dash up such that now you clearly say this has been lifted up to certain distance above HP such that the surface of the lamina is inclined at 30 degrees to HP. Now as you know here, this front view, it is this edge which is parallel to VP. AB or that is AD or CB, that is parallel to VP. Even if you tilt it for certain inclination to HP, you are still moving parallel to VP only. This AD or BC is still parallel to VP. Okay, even if you after tilting, that is why this front view and this front view will be the same. First stage front view will be same as second stage front view. 30 degree you take it because they have said surface is inclined at 30 degrees to HP. Okay, surface is inclined at 30 degrees to HP you do. Now once you do, take the projectors down, get ABCD here on this CD, on this AB, in that way get the top view. Now once you do this, the problem says edge on HP, you please understand, edge on HP is AB. Please understand, edge on HP is AB. Edge on HP is inclined at 45 degrees to VP means you incline it at 45 degree. Second stage top view and third stage top view will remain same because inclination to HP I am not changing. That means in this position AB is on HP such that surface is inclined at 30 degrees to HP and edge on HP is inclined at 45 degrees to VP. That you should understand. Okay. In that way, since inclination to HP is constant, this top view and this top view will remain same. Okay. This position you should know that it is this position. As you are aware here, AB is parallel to HP, true length. CD also parallel to HP. AB in fact it is on HP only, true length. CD parallel to HP, true length. But if you observe here, this AD and BC, they are inclined to HP. They are AD and BC, they are inclined to HP. As a result, they are not in true length. AD and BC are not in true length. Okay, that you should know. Okay, but AB and CD are in true length. BC and AD, they are not in true length because they are inclined to HP. As a result, when you are looking from the top view, this would have lost true length. This would have lost true length. This will not be a true square, but it will be a rectangle. Okay, now what you do is the edge on HP, that is, you see here, edge on HP AB is inclined at 45 degrees to VP they are given. That is why move and copy and rotate in such a way that AB is inclined at 45 degrees to VP. In this way, once you do this, take the projectors to the front and join this, and as a result, you are getting the front view here. Now, you know very well, this position, you understand, in this position, okay, this entire position itself is called change of position. Okay, you can't directly come to this complex position of the surface inclination to HP, VP and all that. We come in stages, first stage, second stage, third stage, in that way. That is called change of position method, COP method. Now you see here, in this position, as you know, first we have drawn a square lamina, then edge on HP, surface is inclined at 30 degrees. That means here, the surface is inclined at 30 degrees to HP. Keeping 30 degree constant, the edge on HP is inclined at 45 degrees to VP I have made. Did you follow? That is why in this position, what you should understand is surface is inclined at 30 degrees to HP and edge on HP is inclined at 45 degrees to VP. When it is in this position, you are viewing from here. You always understand. You are looking in this direction, perpendicular to VP. Direction of vision is perpendicular to VP. In this position, how it is seen? In the front view you have to draw. That is this front view. Top view has already been done. Okay. That means the problem is edge on HP, surface is inclined at 30 degrees to HP, edge on HP is inclined at 45 degrees to VP for this complex position. Okay. You have to write the top view and front view. That is the front, this is the front view and this is the top view. Please follow. This is edge on HP, keeping edge on HP. Okay. Edge on HP, keeping 30 degree constant. If you rotate the solid in the top view, whatever you do, second stage top view and the third stage top view will be same. That is why we take the same top view and write it here in a different position. But this top view and this top view will be same. But here, edge on HP was perpendicular to VP. Here, edge on HP is inclined at 45 degrees to VP. But the top view remains same. But surface inclination to HP, you get it from here. This will not change. No, 30 degrees to HP is there. That is why the square lamina has an edge on HP, surface inclined at 30 degrees to HP, edge on HP is inclined at 45 degrees to VP. In this complex position, when you are looking from the front view, how it appears has been drawn here. That is the front view. The top view is this. This is similar to, this is the 8th problem in VTO. Okay. VTO primer book. Now, a square lamina of sides 40 has an edge on HP and rotate it about this side till it appears as a rectangle of sides 40 by 30 in the top view. Draw projection where edge on HP is parallel to both HP VP. Determine surface inclination to both HP VP and all that. Here, you see here. This is, as you see here, square lamina of sides 40 has an edge on HP. Immediately take edge position. Take edge position. Edge on HP means edge position. 40 mm edge position, square lamina right. B dash, A dash, C dash, D dash and all that. Okay. XY line, VP, HP, everything you draw. This is the 11th problem in primer. Okay. Now, if you see the problem here, square lamina has an edge on HP and rotate it about this side till it appears as a rectangle 40 by 30 in the top view. Okay. Now you see here, when you start tilting this, AB and CD will not change in true length because they are parallel to HP. This is lying on HP only. But AD and BC go on reducing in length. What they are given is, you tilt it in such a way that your top view should be 40 by 30 rectangle. Okay. This should be tilted in such a way that for an observer who is looking from the top, that is top direction, the top view should be 40 by 30 rectangle in the top view they are given. This is what they are given. You just see. they rotate it about this side till it appears as a rectangle 40 by 30 mm in the top view. Okay. In that way, what I'll do is 40 by 30 I'll directly do. This is 40 anyway, it won't change. This 30 I'll do. Okay, A, B, C, D I'll complete. Now, as you know, it is edge on HP. First stage front view and second stage front view should be same because AD or BC is parallel to VP and you are rotating it parallel to VP only. As a result, this and length or this length will be this length. It cannot change. First stage front view and second stage front view here afterwards, you always remember, it will remain same. Like second stage top view and third stage top view. That is why what I'll do is, I'll draw the projectors here, take the same front view length with this as center, because with this center you have to take because edge is on HP. Take this radius, that is 40 mm radius, and cut an arc here using arc command and measure this inclination to HP. This is phi, let us say, for 41 degrees inclination to HP. Okay, your top view appears as a rectangle for 40 by 30. This is the problem. This is the problem 11. Okay, 40 by 30 rectangle in the top view it appears. Okay, it is, that is, they have asked you what exactly is the inclination with respect to HP. You find out this angle, that is 41 degrees. Okay, this front view, same front view, from this point you cut it here so that the edge is on HP and rotated this about this edge. Okay, such that in the top view it appears as a rectangle 40 by 30. Okay, once you get 40 by 30 rectangle, okay, take the projectors up, take the first stage front view and cut it here. In that way you get phi. Okay, this you have to be careful. Okay, next what they say is, draw projections when edge on HP is parallel to both HVVP. Okay, when edge on HP is AB, edge on HP is AB, no, is parallel to both HVVP. That is why you take AB, make it parallel to XY line. Make it parallel to XY line. Second stage top view is same as third stage top view because this inclination to HP is phi, 41 degree. I am not changing the inclination to HP 41 degree. Keeping inclination to HP constant, if you rotate about AB, because it is resting on AB on HP, if you rotate over AB, the top view cannot change. You can take it to any position. Okay, as long as 41 degree is constant, the top view will not change. Now in this way, in the problem given, edge on HP, immediately observe edge on HP is AB. Edge on HP is parallel to both HP VP. It is already parallel to HP because two length here. Now we make it parallel to XY line also. It becomes parallel to VP also. Okay, edge on HP parallel to VP. Make AB parallel to XY line. Now in this way you do. Then once you do this, you get the points. This is A dash, B dash, C dash and D dash. In that way front view you got. In this position you see here. This is, you make X1, Y1. Okay. This is VP. This is HP. RPP. Left view, I'll write it on RPP. Okay. They'll ask you, right view, left view on RPP. If they ask you left view, you do this way. This is the front view in the final position. This is the top view in the final position. For this front view, this top view, how does the side view look like? For that, you draw an X1, Y1 line, draw 45 degree line, you call it as RPP. Now you see here, you go from here, this is the point, one point. From you go here, this is the one point. Then which you are looking from here, no? Always the direction of vision for front view is perpendicular to VP. For top view, perpendicular to HP. For RPP, left view, perpendicular to RPP. When you are looking from here, C is C, D is not seen. C double dash, D double dash. When you are looking from here, B double dash, bracket A double dash. B double dash, bracket A double dash. This is the inclination to HP. This is the inclination to VP. This is front view, top view. This is left view on right profile plane. In that way, you are able to complete one very good problem on projection of square lamina in the edge position. This you should never forget. Okay, that in this position you have written the side view also. Okay, side view also you have written, and as you see here in the side view it is looking like a line. That means in this position, whenever it is in this position, you should imagine that when you're looking from the side, it appears as a line in the side view. When it appears as a line, it should be